Hi, my name is Wan Nazira Fazlin binti Muhammad Saki. Today I will talk about introduction about this project. In this project, we will study about the system that commonly used for bottling and canning, which is the conveyor system. Conveyor system is a mechanical handling system used to move material, product, or goods from one location to another, especially in factory or industry to make flow management of the work to become more efficient. Usually it is used for packaging and transferring process because they can be set up to certain speed in a time to increase the productivity of the factory. In addition, there are industry that use conveyor system in automotive, electronic, chemical, and also other type of sector. It is also important for us to know how exactly the conveyor system work. Okay, for objective, firstly, to understand the modeling of system by its physical principle, to obtain the speed control for the system, and to simulate the system to investigate the system and its performance. Next, for the scope, firstly, to providing transportation to reduce man workload and reducing the consumption of time from one point to the other point, and to create system model by using the software or simulating MATLAB to simulate the work of the system.
Now, I would like to present about the literature review of our project. Conveyor systems are extensively utilized in various sectors, including manufacturing, mining, transportation, and distribution. They offer an effective and automated the process to move objects, minimizing the need for physical labor and improving productivity. A variety of commodities, including solid object, loose tin, and bulk material, can be handled by conveyor system. A conveyor system is a mechanically operated equipment employed inside a manufacturing or logistic facility to deliver product from one location to another. It is composed of several parts that operate together to move things or materials along a specific course, including belt, roller, pulleys, and motorized system. The basic component of a conveyor system include conveyor belt, drive unit, rollers and pulleys, supporting structure, and control system.
Now I will present about review on industrial process control. Principle of process control. Process control is based on a feedback loop comprising a final control element, a controller, a process variable, and a control objective. The main goal of process control are stability, quick response time, and minimizing the difference between desired and actual output. Steady state error represent the deviation between the desired and actual output. Process control strategy. The first strategy is proportional control. It adjusts final control based on the difference between desired and actual output. The next one is integral control. Modify control variable using error between process variable and desired output. The third one is derivative control. Alter final control based on rate of change of error signal. The fourth one is PID control. PID control combine proportional, integral, and derivative control for precise process variable control. The fifth one is cascade control. Cascade control connect controller in series to control process variable connected to system output. The sixth one is feed-forward control. Adjust final control to counteract disturbances using a predictive model. The last one is ratio control. Regulate single output with multiple input to maintain a constant ratio between process variable. Next, I will talk about benefit of process control. The first benefit is higher productivity. The second one is enchanted quality. The third one is disease waste. And the last one is improved safety. Next, I will present about process control implementation. First of all is design. Choose appropriate sensor, transmitter, controller, and final control component to meet process control need. The next one is installation. Set up control equipment and wire it to the operation. The third one is commissioning. Test and modify the process control system to ensure it meets the criteria. The fourth one is maintenance. Inspect, clean, and replace components to ensure proper operation. The last one is troubleshooting. Identify and resolve issue with the process control system.
Next, mathematical modeling. Mathematical modeling is the process of using mathematical equation, formulas, and techniques to describe and understand real-world system, phenomena, or processes. It involves creating a simplified representation of a complex system to analyze its behavior, make prediction, or solve problems. There are a few steps involved when we are constructing a mathematical model for a certain system. These are the examples of basic steps included in mathematical modeling. First, identify the problem, formulate assumption, define variables, establish relationships, construct the model, analyze the model, validate and refine, then apply and interpret. A proportional integral derivative controller or PID controller is a commonly utilized feedback-based control loop method that is applied in industrial control system and other applications that require for constantly modulated control. There are three main components of PID controller including proportional term, integral term, and derivative term. This figure shows the transfer function of PID. An open-loop system is a control system that operates without feedback. This particular type of system does not measure or evaluate the output in relation to the desired input or reference signal. An electric heater is a simple visualization of an open-loop system. A closed-loop system is frequently defined as a feedback control system that uses feedback to modify its behavior and keep a desired output or response. The example of a loop control system application can be seen in controlling the water level in a tank. Other than that, it is applied in a home thermostat, which is also a closed loop system used to regulate the temperature inside a house.
Slide, we can see the block diagram for armature circuit, transfer function torque constant, torque in the motor, and the block diagram for the system with lock, relating the angular speed and the displacement, and function of feedback.
Hi, my name is Ang Zishuan with the number matrix of DD210016, and for my part, I will be presenting about the theoretical calculations and analytical procedures, which will be mainly about the transfer function and the block diagram of the conveyor belt system. So we'll start with the transfer function for the PID controller. So at the top part, we can see the diagram for the PID controller block diagrams. And from this diagram, we can see the equations and formula for all the PID controller, which is the Kp, which is the proportional gain, and the Ki, which is the integral gain, and the Kd, which is the derivative gain. And by summing all of it up, we can derive that the transfer function for the PID controller is equals to the V, which is shown at below. And after by applying the transfer function to the equation that we will be able to obtain will be shown at the bottommost of this slide. Next, it will be the transfer function for the DC motor. This is because a DC motor or the direct current motor will be used to transfer energy and drive the conveyor belt systems. So on the left side, as what we can see, it will be the transfer function for the motor, and it will be rearranged into a new equation because for the induced current, and which will be listed as the equation 1, which is for the transfer function for the DC motor induced current. And on the right hand side, this is because of the theory of the conservation energy is being applied to study about the mechanical dynamics of the DC motor. We know that the resultant torque on the motor shaft will be equal to 0. Thus, the equation on the right hand side can be obtained where the torque is equals to the electromagnetic torque, and it will be rearranged as well in order for the resulting angular rate. And the final equation obtained for this part will be labeled as 2 as shown is in the slide. For this part, we will be talking about the transfer function of the conveyor belt system. And on the top figure, it will be the schematic diagram for the conveyor belt system. And in order to calculate the J-conv and the sum of all the products and mass of the belt constitute the total mass transport by the conveyor belt system, we need to determine the mass moment of inertia of all components that undergo the rotational motions. So the equations or the formula is shown on the left hand side, at which you can see for the first and the left hand side equation, it will be the equation for the mass inertia of all rotating component for the driving pulley and shaft 1. And on the left hand side second equation, it will be the driven pulley and shaft 2 reflected mass inertia to respected to shaft 1. And for the third equation on the left, it is for the idler, the mass inertia to shaft 1. And on the for the last equation on the left hand side, it will be the force required to accelerate mt related to torque about the motor shaft. And on the right hand side, after summing all the equations on the left hand side, we get that the jconv is equals to, as shown as in this slide. We know that the total torque will be equals to the T plus the T, which is torque related to the frictional force. And we know that the T will be equals to J conv, which we obtained from the slide earlier, previous slide, times with the alpha. And the TF, from what we know, by assuming that there is friction happening between the belt, pulley, and idlers, and the N is the number of idlers along the conveyor belt length, we get that the magnitude of the frictional force written in the form related to the torque acting along the motor shaft will be equals to, as shown as at the left hand side bottom equations. And by summing it, we get the overall equations at the right hand side, which is the T, or the total torque. Next, we make the total torque equals to the equation as shown at the left-hand side top part. And by substituting this equation into the equation 2, which we get in the previous slide, we get that the equation equals to at the left-hand side of the bottom part. And since that the conveyor belt system will move a linear distance equal to circumference of the driving drum with the velocity Vb, when the driving pulley spins its circumference in one revolution, we get that the equation equals to the equation as shown at the middle part of this slide. And at the right hand side, we will be substituting the equations into the equation 1, which obtained at the previous slide, and this the equation 3 will be what we get. And from the left hand side equations, we sub in with the equation in the middle also, and we get the equation equals to the equation label number 4 in this slide. And this will be the transfer function for the conveyor belt system. After all the transfer function is obtained and by applying Laplace transform to the equations, the overall transfer functions for the motor conveyor belt system will be obtained, which is shown at the top part of this slide. And the middle of table shows the parameters of the motor conveyor belt systems. And by subbing in and applying all the values of the parameters of the motor conveyor belt system, the equation for the transfer function will be obtained is shown at the bottom of this slide. So the block diagrams will be constructed both manually and also in the MATLAB. So at the top figure will be the block diagram constructed manually, and the bottom figure will be the block diagram constructed in the MATLAB. As what we can see, the step input is connected to the summing point, and then to the PID controller, and then to the transfer function, and then to the output. So that's all for the part theoretical calculations and analytical procedure.
Hello, hi, my name is Kong Ming Chai. My matrix number is DD210014. Today I'm going to present about the result and discussion. There are three main elements in this part. The first one is time response analysis. The second one is frequency response analysis. And the third one is stability analysis. For time response analysis, the step response graph is plotted in the Simulink through MATLAB. So by looking at the pattern of the graph, it is a damn graph and it is stable towards the end. So this is the result obtained from the MATLAB. For frequency response analysis, a Bob plot is plotted in the Simulink through MATLAB. So this is the Bob plot we obtained through MATLAB. So the gain margin is towards the infinity. The phase margin is 39.3 degree. So this is the frequency response that we obtained through MATLAB. For stability analysis, both root locus and Bob plot is used to determine the stability. So by looking at the root locus of this conveyor system, it shows that it is a stable system. So for a Bob plot, since the phase margin is greater than the angle of 30, so we can assume that this system is also in a stable state. And also the gain margin is greater than 0, which means that this system is completely stable. So this is the results obtained from the Simulink And this is all for the part of discussion. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Sadiati bin Muhammad Zulkifli, number matric DD210039. Today I will talk about for the conclusion part and recommendation. For conclusion, the PID controller is used to control the conveyor starting process as a result of the study of the conveyor belt system. It makes the conveyor belt system reasonably controlled, allowing for systematic speed control and smooth startup. This approach purely utilizes the carrying capacity, lowering the power requirement for conveyor belt system. The MATLAB, the MATLAB program was used to develop and generate a graph of the conveyor belt system transient function in order to better comprehend the subject. The conveyor belt system's equations were derived and acquired using simple math and physical principles. Students are able to examine the conveyor belt system's process control systems, time response, frequency response, and stability of the system by using the MATLAB and Simulink application. By analyzing the conveyor belt system from a control engineering perspective, students can assess the performance of the control system itself. This includes evaluating the accuracy, responsive, stability, and overall effectiveness of the control algorithm and feedback mechanism employed in the systems. The analysis also can help to determine whether the control loops within the conveyor belt system are properly tuned. Tuning involves the adjusting the controller parameters to ensure the optimal performance, such as minimizing overshoot, settling time, or steady state error. Next, for recommendation part, here's some ideas for improving the controller system in this application. First, auto-tuning. Auto-tuning minimizes or completely does away with human PIDs tuning trial and error process. Auto-tuning is type of control loop that typically yield terms with values that are close to ideal. However, some manual tweaking is frequently needed to reach the more optimal values. Instead, we must be aware of the type of conveyor belt and the product capacity in order to ensure that the speed system of the conveyor operates more efficiently. The most prevalent problem with conveyor belt is specification correctness, since performance declines when there is insufficient accurate load data. And that's all from me. Thank you very much.